Assalamu alaikum friends. Today we are going to study Newton's second law of motion. Newton's first law indicates that if no net force acts on an object, then the velocity of the object remains unchanged. The second law deals with the acceleration produced in a body when a net force acts upon it. Newton's second law can be stated as if a net external force acted upon a body, it accelerates the body in the direction of force. The magnitude of acceleration is directly proportional to the magnitude of force and is inversely proportional to the mass of the body. If a net force of magnitude F acts on a body of mass m and produces an acceleration of magnitude a, the second law can be written mathematically as a proportional to F, a proportional to 1 by m, so a proportional to F by m, or a is equal to constant F by m. According to SI units, if m is equal to 1 kg, a is equal to 1 ms minus 2, F is equal to 1 Newton, then the value of constant will be 1. Therefore, the above equation can be written as a is equal to 1 multiplied by F by m, or F is equal to ma. First law of motion provides the definition of force. A force produces an acceleration in a body. By the second law of motion, F is equal to ma, we can calculate mathematically the amount of force required to produce a certain amount of acceleration in a body of a known mass. The SI unit of force is Newton. 1 Newton is the force which produces an acceleration of 1 ms minus 2 in a body of mass 1 kg. From equation 3.1, 1 Newton is equal to 1 kg ms minus 2. Effect of force on velocity. Newton's second law also tells that a force can change the velocity of a body by producing acceleration or deceleration in it. As velocity is a vector quantity, so the change may be in magnitude, direction, or both of them. Newton's third law of motion. When there is an interaction between two bodies such as A and B, so the body A exerts a force on body B. The force is known as action of A on B. In response to this action, the body B exerts a force on body B. This force is known as reaction of B on A. For example, when we press a spring, a force is exerted by our hand and the spring is action. Our hand also experiences a force exerted by the spring. This is the force of reaction. Newton expressed this action and reaction forces in his third law of motion. It is stated as for every action there is an equal and opposite reaction. Since action and reaction do not act on the same body but they act on two different bodies, so they can never balance each other. Thus, Newton's third law can be also expressed that if one body exerts a force on a second body, the second body also exerts an equal and opposite force on the first body. Forces act in pair. We have studied that forces act in pair when two objects interact, action and reaction forces. We often notice a force that seems to make something happen, but usually we do not notice the other force involved. Here are some examples of pairs of forces involved in accordance with Newton's third law of motion. Consider a book lying on a table as shown. The force acting downward on the block is the weight. The block exerts a downward force on the table equal to its weight W. The table also exerts a force F on the block. The two forces on the block balance each other and the block remains at rest. When a bullet is fired from a gun, the bullet moves in forward direction with a force F. This is the force of action. The gun recoils in a backward direction, the reaction of force R. Limitations of Newton's law of motion. We have already explained that Newton's law of motion can be explained with very high degree of accuracy to the motion of objects and the velocity which we come across in everyday life. The problems arise when we deal with the motion of elementary particles having velocity close to that of light. For this purpose, relativistic mechanics developed by Albert Einstein is applicable. After all this discussion, we can state that Newton's law of motion are not exact for all types of motion, but provide a good approximation unless an object is small enough or moving close to the speed of light. Mass and weight. Commonly, we consider mass and weight as the same quantities, but scientifically, mass and weight are two different quantities. We say that weight of this object is 5 kg. It is not true. In fact, 5 kg is the mass of the object. The simplest definition of mass is that a measure of quantity of matter in a body. Scientifically, mass of a body can be defined as a characteristic of a body which determines the magnitude of acceleration produced when a certain force acts upon it. It is known as the mass of a body. Mass is a scalar quantity. It remains the same everywhere. Practically, mass is measured by ordinary balance. The SI unit of mass is kilogram kg. Weight is a gravitational force acting on an object. It is a vector quantity acting downward towards the center of Earth. The weight of an object is equal to the force which the Earth attracts the body towards its center. Gravitational field.